Okay. Hello, everyone. I hope you enjoyed yesterday's conference today, and hopefully you'll enjoy today's one. What I would like to talk today is actually a process of log centralization, because I'm not sure how many of you here knows about log centralization solutions. Nice. How many of you used Elasticsearch? Okay. How many of you are aware of and used Logstash, Kibana, or any other stuff like syslog, syslog-ng, and rsyslog? Okay, so the basic problem that we currently have in most organizations that are not small is the amount of logs. And I'll try to show a bit about how to handle that so that not only administrators can use the information and the developers don't need to ask for every time when they need something to give me the logs and I need them. We have tools and I will try to show a bit today. Okay. It works. First of all, my name is Rafał. I happen to be a semi-text engineer and a consultant mainly. First of all, I'm actually a father and a husband, and I happen to write a few books. Maybe you read some, maybe you don't, but yeah, anyway. The current problem, as I said, is that multiple devices currently produce logs, and they usually produce a lot of them. Even in a standard logging environment, when you only log the information that something happened correctly and when exception happened or any error, the amount of logs can be vast. And the problem here is that when they produce them, they are not anywhere near together. You can, of course, take SSH, grab through all the logs, you will find the relevant information. But still, that takes time. And the problem is that you actually can't give a proper meaning to all the amount of information. People think, or when I talk to clients, they've sometimes said, okay, but those are logs. We try to tell them that logs are as important as the business data they have, because actually logs are real data that will help them solve some problems. So imagine that something happens in your environment when an error happens or some machines fails or anything, and you try to give your data, get the data and give it a meaning. I imagine myself usually, not sure if it's working, I imagine myself or a client like this. So where is this stuff? Where does it come from? What actually does it mean? And there is a solution to that. And I think that the solution is log centralization, actually. So you put the logs in a central system that will allow you to search them, to give them a meaning, and it should be more or less in real time. There are tools out there. The problem is that logs from multiple places have different formats. And usually what you need to do is give them first the same common ground, the same structure, and then you can search through them. So the tools that I'll talk about today is the ELK stuff from Elasticsearch, which is actually Elasticsearch, Logstash, and Kibana. Of course, there are many, many other tools that will allow you to do the same. For example, we have Apache Flume that will, the Apache Solar logo is not well visible, but you can push the data to Apache Solar. You can use Fluentd, you can use any syslog-based solution. You can even go and choose the forks of Kibana that are out there and visualize the logs in whatever system you actually use and use to store data. The thing is that you may ask, why is even a search needed? Nowadays search engines, at least the ground I'm coming from, because I'm mostly a search guy, it's easy to find related data with them. It's actually very easy. It's just a matter of a proper query and you get the data. What's more, they are fast, accurate, and allows you to get the data almost instantly. And in addition to that, they allow us to get the data in near real time, and they give us real-time analysis and insights on what the data actually mean. Because returning 100,000 of logs events is actually not super useful when you need to analyze them somehow. So why we usually choose Elasticsearch for that? First of all, it comes with the reasonable defaults that you just get Elasticsearch. It's easy to install. You just get it, and you can run it in a small environment. In addition to that, it is JSON and REST based, so not only machines can talk to Elasticsearch easily, but we can do that as a human. So that's not a problem. It is distributed by design, which theoretically means that we can scale it to handle terabytes of data. And actually we need that because in large organizations, the amount of data that comes from multiple pieces of software is very large, and that can be terabytes of data per day. And finally, it is based on Apache Lucene, the most commonly used full-text search library out there that is small, very efficient, and has no dependencies at all. So you just take the jar and you can build a search engine out of it. So I told that Elasticsearch is easy to install, and what it takes, you just download the proper package, you unpack it, and you are already running with Elasticsearch. The thing is that Elasticsearch is distributed by design, as I said, and it will already work in cloud mode even when only a single server is running. That means that we don't have to do anything, at least for small deployments. But when it comes to larger deployments, it's a bit different, and that's why I wanted to stop a bit and tell about Elasticsearch. First of all, it's scalable. Imagine a situation that we have a single node with an index that contains 6 shards. Now, if we would add another node to that equation, we can add replicas, which means that we have a physical copy of each of the shards on a second server. Now, if you add another node, actually 2 of them, you will end up with data spread evenly across the cluster. Now we can add multiple nodes and the data will be spread automatically without any effort from us. That's actually great because if we keep the data volume under control and use, for example, time-based indices, we can have a cluster that we can control and that can handle the data we have. Of course, the standard configuration options are good enough for small deployments or for development, but for larger ones, we should adjust them. For example, Elasticsearch starts by default with discovery called multicast. What Elasticsearch does actually when a node tries to join the cluster is that it sends a multicast request to the network and finds the nodes or the cluster that has the same cluster name. And you should avoid that at all costs in production. You should rather use a unicast request that you specify a list of nodes that will be queried, and Elasticsearch will do everything on its own then. But in that case, when you use a unicast, like shown on the right, you avoid the thing that some random node joins the cluster. Imagine that your developers use the same cluster names locally that you use in production, and that node or nodes from developers somehow join the production cluster. That can turn into disaster, and that's why we want to avoid what's shown on the left, so the multicast. In addition to that, you should remember to have the minimum master node set to at least to be a quorum of a half plus 1 of your master eligible nodes. That should prevent you from most of the split brain situations, where, for example, when a network splits. That's also pretty important because if you run into split brain situation, you end up with 2 or more distinct clusters that can index data. When they join again together, some of the data will be lost. And finally, for big deployments, you should divide the cluster into separate things. You should have master eligible only nodes that will only work as nodes that control the cluster. You should only have a data nodes that will work as a workhorses. They're holding the data. And finally, the client-only nodes will be responsible for handling the queries and aggregating them for your application that reads them. One thing about Elasticsearch, it's very configurable and allows us to configure multiple things, like the thread pools mentioned here. In general, you don't touch thread pools. And if you want, you really don't want that to do, but sometimes you really want. Why? Because your deployment might be different from the general use cases. You may, for example, have almost only writes, and then you lose threads on the search side because you, for example, may want to run a single query once every few minutes or something like that. In such cases, we can adjust the thread pools. One thing to remember is to use the fixed size, so Elasticsearch is not overloaded. You set the size in the queue so you know how many threads are actually allowed to be executed. And those are the properties that you can find in the documentation to adjust them. There are multiple thread pools out there in Elasticsearch, but we usually are interested only in the three of them: for searching, indexing, and for bulk indexing. The next thing is that we want to avoid out-of-memory errors. Finally, this is Java, and we can run into memory issues. There are a few things that Elasticsearch allows us to do, to configure to avoid having out-of-memory issues. First of all is the so-called circuit breakers that allows us to say how much of the JVM heap is Elasticsearch allowed to use for that particular cache. We have the request breaker, which allows Elasticsearch to refuse execution of the request when it will take more than a specified amount of memory, by default 60%. We have the breaker total limit, which doesn't allow Elasticsearch to use more than 70% of that for requests or field data. And finally, the thing to really remember about is the field data cache. What Elasticsearch uses it for is when you sort, facet, aggregate on the data, it needs to uninvert what's in the inverted index. And by uninverting, it reads the data from the indices and puts that into memory. By default, that field data cache is not limited and is unbounded, which means that you can, if you do enough querying and those queries are complicated, then you can really end up with out-of-memory issues that you can't keep up with memory. So the normal thing I suggest to clients is bound the cache to some amount of JVM heap. Usually you can see that by running the performance tests. You see how much memory you actually need. Finally, the filter cache, that's configurable as well, and we can limit the amount of data that can be put there. The thing to remember as well is that we should avoid indexing a single event, a single document at a time. That's because Elasticsearch has a way to properly index bulk of data, and we should use the bulk API to do that. So we pack the logs into pieces, into buckets actually, and push them together, 100, 1,000, 10,000 of logs at the same time. So Elasticsearch can do that faster when it comes to processing. If you allow a few of the requests to be lost somewhere on the network, you can use the UDP bulk, which is even faster than the standard bulk request. In addition to that, it's sometimes good to limit the amount of operations that are stored in a so-called transaction log, which is a write-ahead log that holds the information about the documents that were sent to Elasticsearch. And to do that, we can limit the number of operations that are allowed to be stored there, and we can adjust the size. Usually, you don't want too many of the data being put there, because when recovery happens, when something bad happens to Elasticsearch, you will end up with long recovery because of the replaying of transaction log. Finally, there is something called refresh. What Elasticsearch needs to give you the newest data that were just indexed is that it needs to refresh the index searcher object. My colleague did a few performance tests some time ago, and with the default 1 second refresh rate, which means that logs are visible after 1 second when they were indexed, we got about 2K logs per second on that machine. However, increasing that time to 5 seconds gave us 25% of increase in indexing throughput. When we increased that time to 30 seconds, we got a refresh. We got an increase of almost 75% to the initial throughput, which means that if you don't want the data to be visible in near real time, and you allow, for example, 30 seconds of that retention time, you will end up in way higher, not only indexing throughput, but as well as a query. It matters when it comes to query performance. You also, I mentioned that earlier a bit, you want to keep your data volume under control. That doesn't mean that you want to limit the amount of data you index. You just want to control where is it placed. The usual stuff you do to make that happen is having time-sliced indices. For example, daily ones that allows us to keep the logs for a given day in a single index. That's not only valuable for having the data under control, but also for querying. If you are querying for only a single day of logs, then you can only hit a single index instead of running the query against all the data, for example, for 2 years that you have stored in your Elasticsearch. The thing is that Elasticsearch allows us to use aliases, a virtual name for indices, that helps us to do that. So instead of worrying on the application side what should happen, we can just create aliases, like the alias for today for indexing and the weekly for querying. And then when we add another indices, we just adjust the aliases, so our applications are still able to use the virtual names, but even when the number of indices grow, we don't need to care about the names of the indices. They can be blah, blah, or anything like that. So, but still the aliases will be used. Finally, you don't want to monitor Elasticsearch in production by doing something like that. So you don't want to open hundreds of terminals and monitor it. You want to use one of the tools available out there, like the SPM we got for Elasticsearch, or any other tools that are not only commercial ones, but also the free ones like Graphite, Ganglia, or anything like that. So if you want monitoring, you actually should want to have monitoring. Logs are not the only thing that should matter. If you want to look at how SPM works, come join us at the booth. I'll skip that. Basically, you can get a lot of metrics, and that's what it matters. We didn't talk about Logstash. We have Elasticsearch configured, and now we want our logs to be processed. The thing that I already said, that the logs come in an unstructured format, which means that Apache logs in another format, your applications logs in another format, mobile devices put data in CSV files, and so on. What Logstash will help us with is making the structure of the logs similar after processing. So first thing in the Logstash is that it has inputs. Inputs is responsible for reading the data. For example, it can read a local file, if that's what we want. After that, from the input, it's passed to a filter. What filter does is it takes the raw input of the data and structures the log in a way that it can be sent to an output and actually result in a real document. Let me show you an example. This is a simple Apache access log, a very simple one. And when passed to log properly configured Logstash, it will result in a log that's actually a structured document in a JSON that is already ready to be sent to Elasticsearch for indexing. If we do that for common formats we want to index, then on the output we have the same structure for each of our logs, and then we can put it to Elasticsearch, for example. In most cases, you don't want to run Elasticsearch locally on the applications. Logstash is quite a memory hog, and you don't want to run it and slow down the application. Because of that, you use a so-called, for example, Logstash forwarder, which was previously called Lumberjack. And Lumberjack will push the data to Logstash, and then Logstash will forward that to Elasticsearch after processing. Of course, that can be scaled as well. So you can have multiple forwarders, or not only forwarders, because, for example, syslog will do the job very well as well. And it can be put into Logstash. Then Logstash can, for example, forward it to a key value store like Redis that will work as a queue. And from the queue, another Logstash instances will put that to our distributed Elasticsearch cluster. Simple as that. Let's now look at a simple configuration of reading the local files. As we said, first we have the inputs in Logstash, which means this configuration actually shows that we want to read a file from a given path, give it a type, which we'll use in just a second, and start from beginning. That's simple as that, and Logstash will do the rest. Then we have a filter. There are numerous filters in Logstash. There are a lot of plugins out there, but we will use a grok. A grok filter allows us to use a common and simple names for complicated regular expressions. Usually people, at least some of our customers, are afraid of regular expressions. So when we show them grok, oh, okay, it's simple. We can use that. And this configuration says that for our Apache access logs, we'll use a grok that will match a message and use a type from the grok dictionary called combined Apache log. And finally, we have the output, for example, Elasticsearch one, that will push the structured process logs to local Elasticsearch, and we'll use daily indices to do that. We use a HTTP protocol, and we set Logstash manage our templates, which means the index structure, so we don't have to care about that at all. Of course, we can use Logstash forwarder, which we can configure, again, very simple. We specified in the network object of the JSON, we specify the Logstash servers that should be contacted. We have files that should be read, and again, the type. And on the Logstash side, we just configure a Lumberjack input that will listen for the data, and that will be read and sent for further processing. Now, if we would try it, it's very simple. It's just a matter of running Logstash with that three configurations combined. And if after processing, if we would run a query against Elasticsearch, we would get a pretty JSON that we can use. But who wants to analyze JSON actually by hand? That isn't the case. So that's where Kibana comes into play, and which allows us to basically build any custom dashboards that will have the thing that we are actually interested in. If this is a very simple dashboard actually, which only shows the 3 logs that we found in the previous example, but in general, if we would like to show maps, if we want to divide the logs into categories or anything like that, we can do that. Using a simple HTTP, Kibana HTTP application, it's very simple to install. You just download the package, adjust the Kibana to point to your Elasticsearch cluster, and that's how things are run around here. So sometimes you don't want to go into your self-hosted Elasticsearch. So that's when SaaS solutions, for example, come in. Like there are a lot of them as well. We provide the Login one that allows you to just take your logs with, for example, Logstash and push them to our environment. This is very simple. Again, instead of having your own Elasticsearch, you just modify it to push it to login receiver sematex.com, and things work as they should. So actually, that's all what I wanted to show you. And the thing is that you should remember that some time ago, I heard that people are divided into two categories: the ones that does backups and the ones that will do backups. The same goes with log centralization, I suppose, that we currently see organizations that I have a lot of logs. What I can do about it? Use log centralization solution, but can I index all them because they are in different formats that have multiple lines like the Java stack traces, anything like that? Yes, you can do that, and you actually should do that. That really helps in handling a lot of applications that you have in your organization. It allows your people to very quickly find what they are looking for, especially when troubles come and when you want to find actually the real solution and what is the root problem of that all. Finally, we are still hiring, so if you want to join our ranks and work on search, big data, or any log-related things, come join us. It's really nice environment. And thank you very much for listening, and I hope you enjoy the rest of the conference.
Do you have any questions to Rafał? Okay.
Yes?
You have two questions?
Hi. Have you, is there any ready-made, maybe Logstash filter or source or whatever that allows you to parse mail messages from IMAP or some other source, or receive emails in some way? Because there's lots of legacy stuff that still sends mail, and you have to just analyze it somehow.
Actually, so the question was if there is any input or filter that allows to process mail messages. I must say that I don't know. I've seen a simple filter for Logstash that combines multiple grok pieces that can filter and can structure the mail. But usually, even if there is no solution out there, it's really easy to build on top of Logstash. Very easy. I can give you an example if you want, just at the booth.
Okay.
Okay.
Thanks.
Okay. Thank you. I'm not. As I said, I come from a search environment. Really. Okay.
Okay, I have another one.
Hi, I got a question. Any good practice to track some users' actions across different log formats, applications? For example, we can imagine that user is, using some service, and there are a couple of different applications behind that, and to connect them together.
I'm not sure if I got the question correctly.
For example, user is bypassing proxy, you are generating some log. He's hitting some web server, you are generating some log. He's querying database, you are generating some logs, and so on, and combine them together to see only workflow for this particular user.
Actually, if you will have that logs already in Elasticsearch, for example, that's a matter of a proper query to Elasticsearch. For example, using aggregations on that user ID. So if your applications, the whole stack, for example, the proxy, the application then can publish the logs correctly, and they are indexed, it's not a problem to find those in Elasticsearch. Yes, you can, for example, have like a session ID or user ID there as a field in Elasticsearch, and you can use Elasticsearch has a notion of aggregations that allow us to do different things on the raw data that was returned by a query. So, for example, a top hits aggregation will allow us to get only structured documents only for that for a given server or for a given user. And in such case, this will be for a given user. And the path, for example, sorting by timestamp here would allow us to see the exact path the user took during his journey through all the pieces of the application. Because that happens in some time, one after another. Yes?
What about running multiple instances of Elasticsearch versus running one instance? So if we have like a big piece of hardware with a lot of disk and a lot of memory,
Okay.
from a performance standpoint, is it better to run many per or?
That's a good question. The question is if it's better to use a single Elasticsearch instance on a big or very big hardware or multiple of them on smaller scales. You usually will get the answer that go, even if you have a big server, go for multiple small virtual machines or multiple Elasticsearch nodes on that machine. That's because of multiple things. First of all, the Java JVM giving too much heap results in problems. For example, with garbage collection, and if you pass 31 gigabytes something, you end up with 64 bits pointers to memory, which again doubles the amount of memory needed for for addressing the same stuff. So usually, small number of Elasticsearch, higher number of Elasticsearch servers on smaller nodes will result in better performance. That's because you can, for example, divide the IOPS for disks, and they won't need to wait for writes and reads. You can better adjust the caches of the operating system, which is very important when it comes to the performance of Elasticsearch, because you don't want to have JVM taking up a lot of gigabytes of memory. You rather spend that for the operating system cache, because that will be reused.
We have last question over here.
Hi, I'm Zoltan. I'd like to ask you, told that you just download Elasticsearch and it just goes. But have you ever encountered a very big cluster? So I'm interested in, does it become an operational hell when it goes to tens or hundreds of nodes, or is it scaling up nicely?
Okay, the question was if I showed that you can just download Elasticsearch and run it, and if it's become an operation hell to manage hundreds of servers. Usually operations people said that it isn't a problem. That's because of automation. But you should remember that the defaults of Elasticsearch are not well prepared for such large deployments. They can work well with small, for example, developer nodes on really small clusters. But when it comes to bigger ones, you should adjust, like I said, some of the configuration should be adjusted, like, for example, not using multicast, because that can lead into multiple problems when handling of the cluster. I think we don't have much time. Thank you once again, and if you have any more questions or you would like me to show you something, I'm available for the whole day. Thank you once again and have a good day.
Okay, thank you so much.